Hey, folks, we are going to dive right on into the next topic, which is the topic of limiting reactants. When you do a reaction, okay, basically something is always going to limit the amount of products that you can get. So let's say that you have an entire swimming pool of water, let's say, and you have a little tiny nugget of sodium, and you drop the little tiny nugget of sodium into the pool of water. Will all of the water react with the sodium? Of course not, okay, because it's just a little tiny rock of sodium and a whole pool full of water. But all of the sodium will react, okay? So what that means to us is that sodium was our limiting reactant. The amount of sodium that we had limited the amount of products that we could get, okay? The water didn't limit it. We had all the water that we could have ever needed, but the sodium limited the amount that we could have used. Okay, so here's what I want to do to show you a little bit about limiting reactants. Okay, let's say that you want to make 5 hamburgers. Okay, and so you go to the store and you buy 5 hamburger buns. Wish that would get out of my way. Okay, you go to the store and you buy 5 hamburger buns. Okay, 3, 4, 5. Okay, there's your 5 hamburger buns. And you buy 5 pieces of meat. There's 1, and 2, and 3, and 4, and 5. And you buy 5 pieces of lettuce. 1, 2, 3, 4, 5. And you buy 5 slices of tomatoes. 1, 2, 3, 4, 5. And lastly, you buy 5 strips of bacon. 1, 2, 3, 4, 5. Okay? And then you get home and you realize that for every one burger that you need 2 pieces of bread. Okay? You need 1 piece of lettuce. You need 1 piece of meat. You need 3 tomatoes. And you need 2 pieces of bacon. Okay? How many burgers are you going to be able to make? Okay? You're actually only going to be able to make 1 burger. Okay? The reason you're only going to be able to make one is because you only have enough tomatoes for 1 burger. Okay? These extra 2 tomatoes here, these aren't enough to make another burger. So even though you wanted to make 5 hamburgers, you can only build one because your tomatoes limited the amount of products that you can make. Okay, so that's the idea behind limiting reactants. So what we want to do now is we want to see how this translates to a chemistry problem. Okay, so let's go ahead and take a look. So this problem says that we have 15 grams of hydrogen. Okay, so let me put down my hydrogen real quick. Plus 40 grams of oxygen. And this is in the synthesis of water. Okay, so I need to make sure that I balance this. So I'm going to put a 2 here and a 2 here. What's the theoretical yield of water in grams? Well, now I've got a situation that I haven't quite seen before. I've got 15 grams of hydrogen. And I've got 40 grams of oxygen. So now I've got two things that I'm starting with, okay? So what that means is that what I'm going to have to do is I'm going to have to do 2 mole roads and 2 T-charts, okay? Let's go ahead and just do that. So I'm going to go 40 grams of oxygen to moles of oxygen to moles of H2O, and moles of H2O to grams of H2O. Okay, same thing with hydrogen. I'm going to go grams of hydrogen to moles of hydrogen to moles of hydrogen, and then moles of hydrogens to grams of H2O. Okay, so I need to do 2 T-charts. So let's go ahead and do both. So I'm going to do 15 grams of hydrogen, and then we're going to go from grams of hydrogen to moles of hydrogen to moles of H2O, and moles of H2O to grams of H2O. Bring down everything else, grams, moles, moles. And let's go ahead and plug in what we know. So I know 1 mole is 2.02 grams. My mole to mole ratio is actually 2 to 2. And 1 mole of water is 18.02 grams. So let's go ahead and type this in to our calculator. And so I get 15 times 2 times 18.02 divided by, open parentheses, 2.02 times 2, close parentheses. So with this 15 grams of hydrogen, I can make, to 4 sig figs, 133.8 grams of water. Now, that's assuming that my oxygen doesn't limit me, okay? If I have all the oxygen in the world, I can make 133.8 grams of water, okay? Well, let's see how much water I can make if I have 40 grams of oxygen. So 40 grams of O2. Same thing, okay? Grams of O2 to moles of O2. Moles of O2 to moles of H2O to grams of H2O. Bring everything down. So 1 mole of O2 is 32 grams. My mole to mole ratio, 1 mole, 2 moles. 1 mole of H2O is 18.02 grams. Okay, so now let's do the math here. 40 times 2 times 18.02 divided by 32. And I get 45.05 grams of H2O. So that's assuming I have all the hydrogen in the world, okay? Now we need to determine which one is our limiting reactant. Okay, the way that we determine the one that's the limiting reactant is by figuring out which one made less, okay? So if I had 15 grams of hydrogen, I was able to make 133.8 grams of H2O. If I have 40 grams of oxygen, I'm only able to make 45.05 grams of H2O, meaning that oxygen is going to be my limiting reactant, okay? This also means that my theoretical yield is 45.05 grams of H2O, okay? What's the limiting reactant? Oxygen. How do I know? It made the smaller amount. Made smaller amount. Okay, how many grams of the limiting reactant are left over? Tricky question. How many grams of the limiting reactant are left over? Well, the limiting reactant was the one that ran out. So since that one ran out, I know that I have 0 grams left over. That's it. How many grams of the excess reactant are left over? Well, that I'm going to have to do a little bit of math for. Okay, so what I want to do, this is fun. You're going to like this part. Actually, you're going to love this part. All right, so what you're going to do now is you're going to say, okay, if I've got 40 grams of O2, I want to find out how many grams of H2 I actually used. So watch what I'm going to do. I'm going to go grams of oxygen to moles of oxygen to moles of H2, and then moles of H2 to question mark grams of H2 so that I can find out how much H2 I actually used, okay? So I've got 40 grams of O2, and we're going to go from grams of O2 to moles of O2, moles of O2 to moles of H2, moles of H2 to grams of H2. Bring everything down. Okay, 1 mole of O2 is 32 grams. A mole to mole ratio, 1 goes with O2, 2 goes with H2, and 1 mole of H2 is 2.02 grams. Remember, this is going to tell me exactly how many grams of hydrogen reacted with oxygen. So I've got 40 times 2 times 2.02, enter, divided by 32, and I see that I used exactly 5.05 grams of H2. Well, if I used 5.05 grams of H2 and I started with 15 grams of H2, I know that 15 minus 5.05 is 9.95 grams. And that's how I tell how many grams are left over. I also want to know it says the reaction was done in a laboratory environment. 43 grams of water were actually collected. What's the percent yield? Well, here is my theoretical yield. My actual yield is 43. So of course I just plug that into my percent yield formula where percent equals A over T times 100. Okay, so percent would equal 43.00 divided by 45.05 times 100. Let's do the math. 43 divided by 45.05. Enter. Times 100. Enter. How about 95.45% efficient? Yay. All right. And that's it. Okay. That's how you do these problems. That's actually the only one I'm going to do for right now. We're going to do more in class. Okay. These are long problems to work, and we're going to keep practicing. Have a great day, folks.